Hi, I'm Christopher Goodwin.
And I'm Sierra Fox. We're graduate students here at the University of Rochester Department of Biochemistry.
And here at the University of Rochester, we're using cutting-edge techniques to advance our science.
One of these techniques you may have heard about in the news recently is CRISPR. CRISPR is helping scientists edit DNA, the building blocks of life. I'm using CRISPR to change how mouse blood regulates its DNA.
I've also used CRISPR to make human lung cells that are more resistant to viral infection. But why is this new and exciting? What was stopping us from doing this before? If our DNA is a library, older techniques were like using a card catalog, inefficient, slow, and expensive. We have a lot of genetic material in us. It's hard to target what you want. There's so much information here that Sierra is having a lot of trouble finding the book or section of DNA she wants to work with. By contrast, CRISPR is a PC, quick and efficient. We can find any book in the library with a few keystrokes. Looks like our graduate students had more luck this time. Once we have our book, CRISPR can be used in a variety of ways. If our book is a piece of DNA, we can target and change a single word, remove an entire page that we don't want to be there, or we can even make much larger alterations to huge amounts of DNA, changing the story entirely.
CRISPR is changing how we do work here at the University of Rochester and across the world. Recently, Dr. Feng Zhang, one of the creators of CRISPR, came to give us a talk about his work. Here's a picture of when I got to meet him.
Because of the work of scientists like us, new variations on CRISPR will undoubtedly emerge, resulting in even more nuanced ways that we'll be able to make small alterations to genetic code. We're excited to be working with this technique and helping push the boundaries of science into the future.